Hello my senior tools, you're welcome to this lesson. This morning we will be looking at rationalization of the denominator. In the previous lesson we looked at rationalization when we had only one square root in the denominator. For example, we say that, for example, in case you have to rationalize an expression like 3 root of 2 divided by maybe 5, maybe divided by 2 root of 5. Like that. But what we said last time is that in case you want to rationalize the denominator, you simply get the denominator and you multiply it by both the denominator and the numerator. In other words, we said that this is the same as 3 root of 2 divided by 2 root of 5. So multiply the itself, the denominator, 2 root of 5, and in the numerator also have to multiply 2 root of 5. So we said that when we're multiplying these, it is the same as having 3 root of 2 times 2 root of 5 in the numerator, and in the denominator I have 2 root of 5 times 2 root of 5. So we say that this is the same as we multiply those numbers that are outside the square root sign, like this 3 and the 2, likewise the 2 and the 2, and then multiply those ones under the root alone as well. In other words, this is the same as 3 times 2 times root of 2 times root of 5 times 5, sorry, like that. Then divide by 2 times 2 times the root of 5, of course, times root of 5 as well. You can put everything under root like this. So this is the same as 3 times 2, that is the same as 6, and in a root 2 times 5 we get 10. Okay, that divide by 2 times 2, that is 4, and a root we have 5 times 5, that is 25. But of course you can see that 25 has a root which is the same as 6 root of 10 divided by 4 times 5. So you can see that this is the same as 6, let me write down here, 6 root of 10 divided by 4 times 5, that is 20. So when you reach there, you can simplify. By 6 divided by 6 divided by 2, you get 3. 20 divided by 2, you get 10. And our final answer therefore becomes, let me write it above here, our final answer becomes 3 root of 10 divided by 10. That is our final answer. So that is what we looked at in the previous lesson. In today's lesson, we're going to be rationalizing the denominator, whereby we have to add or to subtract roots in the denominator. This is what I mean. You can have these examples here. Rationalize the denominator in the expressions below. Part A says that rationalize root of 2 divided by root of maybe 3 plus root of 5. So in this expression here, you can see that in the denominator we have 2 roots which we are adding. They can be addition or subtraction, whatever it is. So in case we have something like this, what we do is very simple. We simply multiply both the numerator and the denominator by the conjugate of the denominator. In other words, conjugate means that you're going to multiply with the opposite sign. Where we had the addition, put there the subtraction. So this is the same as root of 2 divided by root of 3 plus root of 5. So you multiply the denominator by root of 3, where we had this plus, put there a minus, minus root of 5. Do the same in the numerator, times root 3 minus root of 5, like that. So this is the same as root of 2 into brackets root of 3 minus root of 5 divided by root of 3 plus root of 5 into brackets root of 3 minus root of 5, like this. So from here we do it normally, like we open the brackets and then we expand normally, like we did some time back when we were factorizing. So this is the same as the numerator. I'm multiplying root 2 times root 3. I'll get root of 2 times 3 minus root of 2 times 5. Divide by, in the denominator here, I'll be having root of 3. So I'm going to multiply this root of 3 times whatever is in the other bracket. Times whatever is in the other bracket. So I'll get root of 3 into brackets root of 3 minus root of 5, then plus root of 5 into brackets root of 3 minus root of 5, like that. So still I simplify this by expanding whatever I have in the denominator. Meanwhile, in the numerator I multiply, and on this I'll end up with root of 6 minus root of 10 divided by, so I expand what we had in the denominator. In the denominator we had, so when we expand, when we remove the brackets, the denominator, this is what we get. And when we reach this step here, we shall simply say that this is the same as root of 6 minus root of 10 divided by root of 3 times 3, that is 9. You can even just write 3 because it is the square root of 9. Then minus root of 15 plus root of 15 minus root of 25. Still, when you simplify this, you'll get a root of 6 minus root of 10 divided by root of 9, that is 3, minus, so here you can see that the denominator, actually the root of 15 cancels out because one is a plus, one is a minus, so these ones here cancel out. So we shall end up with 3 then minus root of 25, that is 5. So meaning that our final answer will be equal to root of 6 minus root of 10 divided by negative 2 as our final answer. So we have removed the square root sign in the denominator. We have rationalized the denominator. You can even write this in the more simpler way of writing it as negative a half root of 6, or simply root of 6 divided by negative 2. Negative divided by negative, get a positive. So we shall have minus root of 10 divided by minus root minus 2. Sorry. Let me just repeat this. The other way you can write this final expression here. We can as well write it as root of 6 divided by negative 2 plus negative root of 10 divided by negative 2. So you can see that we can write this one as negative a half root of 6, then plus a half root of 10. Why am I having this? I'm having this because sometimes they may say that rationalize the denominator and write your expression in the form, the first variable of this other part above here, and write your final answer in the form a square root of b plus c square root of d. So when you compare our answer, the final answer, we have got negative a half root of 6, then plus a half root of 10. So we have written that expression in that form, a root b plus c root d. And here they can even add on the question that state the value of a, state the value of b, state the value of c, state the value of d. So you can simply quote and say that our a is equal to negative a half, our b is equal to 6, c is equal to a half, and then d is equal to 10. That is just as a by the way. That is just as a by the way. So we can have as many as possible. We can have as many as possible. Ogambat. So we can even try out this question here. It says that 3 divided by root 5 minus root of 3. So still what we do, it is the same thing here. Simply multiply the denominator by its conjugate. In other words, where there is a negative, put there a positive. And do the same in the numerator. Like that. So you multiply like we've done, and then you continue normally. So that is what you call rationalizing of the denominator in Surds. So I'm going to stop there. You can complete this, and then you can hand in the work for marking. I'm going to send you some work for marking. Otherwise, have a good day.